Good morning, everyone here in the room and on the web. Fantastic to be here back in this great event, the second SDN and OpenFlow World Congress. In the short time I have today, I would like to talk about the work that we have done since last year, and as Dan Pitt mentioned, Congress to Congress progress report. So I remember last year when I was putting the slides together, I was having a hard time selecting a few use cases that I could talk about during 25 minutes. This year we have done so much work that I had a hard time picking the use cases out of a long list of things that we have done since last year. It is great to see the acceleration of SDN adoption in the industry, both on the data center side as well as on the carrier side, as previously mentioned. And my thanks to Layer 123 for organizing such a great event. I'm Justin Dustzadeh. I'm the CTO of Huawei's Fixed Network Business Unit, which is responsible for all carrier infrastructure products, including access, IP transport, and cloud networking. And in my role, I speak with a lot of customers, and I take part in the discussion on the evolution of their networks. And I can tell you that every single operator I speak to wants to know more about SDN and wants to know how SDN can help address their problems. And I have seen a trend shifting from show me that SDN works to show me how much it cost me, whether it can scale, and now show me how it can migrate to SDN from where I am today. So a lot of great progress has been happening since last year. Before I start, I wanted to congratulate all of you for being here and for being part of history. We are making history, really. Usually I talk about things that have been happening in the last few years, but today I wanted to take a broader approach, really looking at the broader industrial revolution since decades and centuries ago, and we are really at the inflection point and at the transition point between the telecom networking industries and the internet and IT industries. And many of us who have been in the networking business over the last 10, 15 years know this kind of evolution graph. We have worked a lot on making the PSTN networks perfect, and then with IP, we all had to embrace that transformation over to IP, and now with SDN, network function virtualization, and cloud, this is really the next wave if we want to be part of that revolution. This is a slide that I showed last year. I will continue to show this until we have only the box on the right, left. Carriers have been going through this transformation since 10, 15 years ago, as was mentioned by Axel. Really, it's about convergence, migrating to IP, simplification of the network. As data and applications are all moving to the cloud, how can we build simpler networks, leveraging the IP, and building networks that can talk to applications and applications that can really leverage the network functionalities in an agile way. When you look at the carrier networks, it's a very complex landscape. Carrier networks have been built over the decades using a lot of proprietary hardware and equipment from many vendors. It is very cumbersome and difficult to introduce new services and to change things. I will not go through all the different things that you can find in a carrier network, but I would like to mention that all these network elements today include a lot of functionalities embedded in software, embedded in the hardware. We see an opportunity really to embrace the IT industry trends and moving things into the software and really leverage the cloud technologies, taking as much functionality as possible from these complex, expensive, proprietary devices, put them in the network, in the cloud, and allow the network operator to choose their hardware of choice if these software functionalities can be run on general purpose processors or commodity hardware. As Axel mentioned, probably for some time, or at least for foreseeable future, some of these functionalities still need to be run on a custom ASIC hardware. We see several categories of functionalities that can be moved to the cloud. The first one is all the mobile core functionalities, layer 4, layer 7 technologies, and some of the high-touch functions. We see that category as a low-hanging fruit. I think Moore's Law has allowed us today really to move a lot of these functions to the cloud. The second part is the network control functions. And that applies both to packet, circuit, and optical. I will cover some of those use cases in the next slides. And finally, there are all the typical IT apps and the walled garden services that are provided today by service providers, whether IPTV solutions or OSS, BSS applications. A lot of these functionalities can today be moved into a cloud environment. Focusing on the SDN part, our end-to-end carrier SDN vision is simple. If we are embracing the software trend, we need to build open SDN solutions. Otherwise, we would go back to the old vendor lock-in paradigm where we would build things with proprietary APIs on top of closed environments. Of course, we would like to promote multi-vendor interoperability. That's what customers want. These solutions should be standards-based, and we see ONF, the Open Networking Foundation, as the leading standardization organization to drive the standardization of SDN and southbound interfaces. We are trying to make OpenFlow as carrier-grade as possible. As Danpid mentioned, there is now a carrier-grade SDN discussion group within the ONF. I also have the honor of serving as the chair of the migration working group within ONF that is chartered with helping operators migrate from today's networks to an OpenFlow-based software-defined network. And when it comes to carrier networks, because of the diversity of the carrier infrastructure, and because each network segment has its own set of requirements and characteristics, we see an opportunity for building task-specific controllers across the network with an orchestration layer that is able to create a relation between these controllers across the layers and across the different network segments to provide an end-to-end visibility and control on top of the physical infrastructure. To build this, this platform and really to make this vision a reality, we have defined the SoftCOM vision, which is really Huawei's vision for the evolution of networks based on software-defined networking, network function virtualizations, and cloud computing technologies. There are 4 guiding principles behind SoftCOM. The first one is to build an infrastructure to enable internet-centric operations. As Axel mentioned, really carriers need to transition from the traditional telco-centric operations to an internet-centric operations to allow web-scale operations of the network, to allow users to do things that they can do today with over-the-top services, for example, and to really build a very scalable infrastructure for agile operations. The second one is to build cloud-based IT systems. As I mentioned, a lot of the infrastructure components in today's telecom environments are very proprietary. There are disparate islands of proprietary technologies that do not talk to each other. How can we help operators build a cohesive, common infrastructure where they can deploy these IT functionalities and systems flexibly for different purposes? The third guiding principle is building a centralized network control for different parts of the network leveraging cloud technologies. So I call that cloud-based network control, where a lot of these network control functions reside in the carrier clouds within the carrier environment. And finally, it's about the virtualization of many of the network functions that can be built in a much better and more elegant way, leveraging the cloud technologies. So the combination of these principles really define the foundation of Huawei's SoftCOM vision. We have created a SoftCOM Biz program, Business Initiatives Zoom In, to sit down with our customers, to understand their pain points, and to help build use cases that address real needs of our customers. We have a long list of use cases and things that we have built since last year with our customers. In the interest of time, since I have only 13 minutes left, I will briefly cover a few of these use cases spanning the mobile broadband network with SDN-based mobile backhaul, fixed broadband access with virtualized residential gateway and virtual set-top box functionality, GI LAN and cloud IMS for the mobile packet core part, and the SDN-based transport network virtualization. The first use case is the SDN-based mobile backhaul. So this is the part of the network where mobile traffic is carried between the base stations and mobile devices onto the core of the network. Because of the great scale of today's mobile networks, a lot of challenges exist today, and these challenges will get tougher over time. So we have built a prototype, or we have started a collaboration with one of our customers, China Telecom, on how we can leverage SDN to manage these IP RAN and mobile backhaul networks much more efficiently. So China Telecom is thinking about deploying up to 400,000 devices over the next 2 years for their mobile backhaul networks. And you can imagine that even if you can achieve a few percentage saving on the CapEx and OpEx of this network, you can achieve a very significant overall savings. And actually, through our joint analysis, we have concluded that we can achieve up to 90% of cost reduction, both for OpEx and CapEx, simplifying the end devices, the cell-side routers, and centralizing the control and management of these networks. I think the SDN benefits are well known for this type of network environment. You can read this later. But we have built this on real Huawei products using our cell-side routers, the ATN series, as well as the aggregation router devices. The next use case is on the fixed broadband side, focusing on virtualizing the residential gateway function and the set-top box devices in the subscribers' homes. The idea is really to take out as much functionality as possible from these end devices and to move these functionality into the network, therefore making these end devices simpler and creating new possibilities for new functions that were not previously feasible. In this implementation, we have built this SDN functionality on our OLT device that can manage up to 2,000 end devices. In the next release of this product, we are thinking about building a standalone version of this controller to manage an even greater number of these devices. For the traffic steering for GI LAN, that's another interesting use case. The GI LAN is part of your mobile network where service enablers are being used to offer value-added services and to traffic and steer traffic in different ways for different applications. So there are challenges today. The way these networks are built is quite static. These are based on point products that have to be scaled for overall maximum capacity. And there are better ways of building these GI LAN networks. For example, if you have a central SDN controller, you might want to steer traffic differently for different applications. You might want to traffic HTTP video through a different path than if you have HTTPS traffic, for example, or you might want to define a default path for all your traffic. This type of dynamic, agile, multi-dimensional control is not feasible today with existing networks. And the overall benefits include a TCO reduction, both for CapEx and OpEx, and also the possibility to do things that are not possible today. Similarly, for the IMS and other packet core functionalities, there is a great opportunity to build these things in a virtualized environment and really to help operators use the same pool of common shared resources across different mobile packet core functions in a more flexible way. And we are working with a number of customers on this real use case. Benefits include elastic, zero-touch, and multi-tenant operations, smooth migration among devices, and multi-purpose shared pool of resources, as I mentioned. We have defined a cloud IMS roadmap since last year. We have finished our demo and prototype. We have a solution that is ready for testing, and we will have a commercial deployment next year. The next use case is the SDN-based transport network virtualization. This is another interesting use case that really allows network operators and transport operators to monetize their network in ways that are not possible today, and to manage their infrastructure in a much more effective way. The idea is to build a transport controller that can run, that can allow a virtual view and control of the physical infrastructure to higher level applications and customers. So that's the simple idea, but we have taken this to the next level, and as was described by Lyndon yesterday during his presentation on Optical Transport Working Group, we see an opportunity to really build another layer of client-facing control on top of these transport controller. Many operators do not feel comfortable providing a direct access to their infrastructure elements to end users or to other entities within the organization. So we see an opportunity to build an architecture based on CDPI controlled data plane interface using OpenFlow, controlling the underlying devices, and building a CVNI, which is a control virtual network interface, and having two types of controllers, the transport controller and the client controller, to allow different tenants of the network, or to allow different users of the network do different things with their own virtual slice of the network. For example, you can imagine a number of virtual network services that tenant A will see the network in a different way and will manage its own portion of the physical network in a different way. Let's say if tenant A is a multi-site enterprise network, through a self-service portal, he might be able to say, this is how I want to manage the bandwidth and the SLAs across my different sites for this time of the day, et cetera, et cetera. And also you can imagine that a router controller can work on top of this transport controller to build an IP optical kind of a cross-layer optimization. Just to give an idea of our approach for building these prototypes and demos, last year we started building a very simple demo of this concept based on a simulated network environment. Then in Germany, at the first SDN and OpenFlow World Congress event, we showed a TSDN transport SDN prototype to show DCI, data center connectivity using OTN. Then we took this to the next level, added some flex optical functionality. And then here outside, I invite you all to go and see our demo. We have built a demo of what I just showed on previous slide, virtual network services with these two types of controllers, both leveraging OpenFlow. And this sits within a broader kind of transport network virtualization paradigm where you can offer multiple views of the physical infrastructure to different customers and network users. So I will not go through all the details, but this slide basically shows that a client controller can see a network in its own way, and other client controllers can see the network and manage their portion of the network differently. And through orchestration between different controllers, you can build an end-to-end, in this case, LAN, WAN, data center networking, really. This use case, for example, is valid for an enterprise customer that has its own on-the-premise data center or mini data center. They are working with an ISP to have connectivity to the network, and the ISP can offer data center services to that same customer, or these entities can be different. And for scenarios such as cloud bursting or other things, you might have a need for dynamic provisioning of bandwidth between these different parts of the network. And with this architecture, you can enable such functionalities. You can take this to the next level, and you can imagine that you might have several transport operators for an even broader end-to-end picture, data center to data center connectivity. Since I have only a few minutes left, I want to talk about an interesting technology that we have been working on, which we really see as an evolution of the forwarding plane. So I think I don't need to tell you that the SDN is really about moving from the legacy model where control and forwarding are integrated into the same physical box into a separated model where OpenFlow is used as the southbound interface. But we really see an opportunity to take this to the next level and to make these devices even more programmable and to basically put as much intelligence and protocol knowledge as possible in the controller. Today with SDN and OpenFlow, these forwarding devices still need to know about the protocol semantics and behavior and all the things that go with today's protocols. If you are building a custom algorithm, for example, it is very hard to build that today with OpenFlow and really to implement that as a network operator into your own network. And this is really about a migration from a black box model to a gray box model to a complete white box model where you can use the same device for different purposes. You can program your device to be an MPLS switch today, and tomorrow it can be a firewall. And the device can be so simple that through some generic instruction sets, you can simply tell it to go to the bit X, to look up the next Y bits, and take action Z. And this can be fully programmable. This can allow the user of the network or the operator to be an integral part of this application development process and not to have to go through the vendor process for adding these extensions and protocol-specific functionalities. And this model, of course, supports both the legacy layer 2, layer 3 protocols as well as any new custom protocols. We have built this on a real Huawei product, and we have a demo of it outside. I invite you all to take a look at it. And since we're running out of time, I'm wrapping up my presentation here. SDN is here to stay. It is impacting both carrier networks as well as data center networks. And we, as a vendor in this community, we are committed to building open standards-based solutions for SDN. We are building these solutions with customers. and we are investing in SDN and NFV innovation and products. I would like to end my presentation with this great quote from Nelson Mandela: "It always seems impossible until it's done." Let's do it together. Thank you very much.